In lesson 5, we're talking about factoring linear expressions. So it says, find the GCF of monomials. First of all, in this paragraph, it's going to say a lot, or it's going to say monomials a lot. Just so you understand, a monomial is a single term. Okay? Remember when we have something like our terms are separated by signs. So here's a term, here's a term, and here's a term. Okay, so a monomial is just one term. So 18 is a term, 24 is a term. Okay, so a monomial is one. Binomial would mean two terms. Polynomial would mean three or more. Okay? So it says, to factor a number means to write it as the product of its factors. A monomial can be factored using the same method you would use to factor a number. The greatest common factor, GCF, of two monomials is the greatest monomial that is a factor of both. Okay? So we had found GCF earlier in the year for something like 18 and 24. Remember, this is when we did our upside down birthday cake method. So 18, we said you can divide out the prime number 2. That gives me 9. 9, I can divide out the prime number 3, which gives me 3. 3, I can divide out the prime number 3, and that gets me 1. When you get down to the bottom, remember, it's like these are all the layers of your birthday cake. That's the candle on the top. So for 18, it's 2 times 3 times 3 times 1. Then for 24, I can divide out a 2, that's 12. I can divide out a 2, that's 6. I can divide out a 2, that's 3. And I can divide out a 3, that's a 1. Now, remember, you couldn't divide out a 4 here or a 6 here because those are not prime numbers. You only divide out your prime numbers. That's why it's prime factorization. So 2 times 2 times 2 times 3 times 1. So our greatest common factor, that's the greatest amount that they have in common. Well, they have one set of 2 in common, and they have one set of 3 in common. Okay? They don't have any more 2's in common because there's not more 2's here. So they have 1 2 in common, they have 1 3 in common. That means my GCF here would be 6. So it works the same way, remember, when it's a monomial with variables in it. Okay? We look for what numbers they have in common, then we just also include the variable that they have in common. So for example, this one. My first upside down birthday cake, I have 12, so I can divide out a 2, that's 6, a 2, that's 3, a 3, that's 1. Then 28C, I can divide a 2, that's 14, another 2, that's a 7, and a 7, that's a 1. And I'm going to put the C down here. It's almost kind of like the flame on the candle. Okay? So what they have in common, let's make that look a little bit more like a 2. I see a 2 in common. I see a second 2 in common. And that's really it. I mean, they have a 1 in common, but the 1 doesn't really help us out at all because anything times 1 is just itself. So I have 2 times 2, which would mean our GCF is 4. Now, with something like this, I have a variable in common. So when I do my 15, that's 3, 5, 1, and 25, that's 5, another 5, and a 1. The 25 had 1x, the 15 had an x and a y. So when I look at what I have in common, I have a 5 in common, and I have an x in common. So 5 times x means my GCF is 5x. Okay? The GCF is really important because what you are doing when you look through your GCF is, or when you go to factor, the first thing you do is find your GCF. So, number 1, find GCF. So my 3x plus 9, my GCF of 3x and 9, let's go ahead, that would be 3, 1, x. Second one would be 3, 3, 1. So the GCF would be a 3. Okay, so the second step is divide each term by the GCF. So I have my original problem, and I'm going to divide by that GCF of 3, each term. Okay, so when I divide, that gives me 3 divided by 3 is 1, so it's just x left. 9 divided by 3 is 3. So then the very last step is to write our answer. When we write our answer, we write the GCF, and then in parentheses, kind of going with our cake theme, our birthday cakes, okay, it's the leftovers go on the inside, okay? So what I mean by leftovers is kind of what we did here. So if I'm factoring out a 3, that means I took away this 3 in each one. So all that's left here is a 1x. All that's left here is 3 times 1 is 3. So the leftovers would be x, keep the same sign, and 3. Okay? So you don't have to think it through this way. This step is doing that. This is finding the leftovers by dividing it out. And the GCF goes in front. So you can think of factoring as undistributing, because before we looked at problems like this as the start, and then we distributed 3 times x is 3x, 3 times 3 is positive 9. And we would distribute to find this answer. Now we're starting with this and we're working backwards to this. Okay? So another example, and they have a couple down here. They don't quite work it through exactly the way I showed you, but it's the same method. If you find that you have a GCF of 1, there is nothing that's in common besides a 1, you would write cannot be factored on that one. Okay? So let's look at these. 4x plus 28. So I have my 4x, I have my 28. I need to find my GCF. So I can divide by 2, 2, and my x. I can divide by 2, 2, 7, and I'm done. So my GCF is 4 because I have 2 2's in common. Okay? So now I factor out my original problem by the GCF. So I'm going to divide out 4 on each part. That gives me x plus 7. Okay? To finish off our answer, I put that in parentheses and put my GCF up front. So now that when I check it, 4 times x is 4x, 4 times 7 is 28. The next one. So again, 3, my GCF, I do my upside down birthday cake, it's a 3 and a 1. 33 is 3, 11, 1, x. This one only has a 3 in common, so my GCF is 3. So that means I go through and divide by 3 on both parts. If I divide by 3, 3 divided by 3 is a 1. And 33x divided by 3, that would be 11x. And again, you can kind of see by doing this, it's what we didn't circle here. Here I didn't circle a 1. Here I didn't circle 11 times 1 times x is 11x. Then to finish our answer, we'd put it in parentheses and put the GCF out front. Now, I won't be too picky on this because this is a long process in itself, but remember, we do tend to write our constants last. Okay, so that's kind of the best way to write that answer. I would still accept this though. And the last one here, 4x and 35, that's 2, 2, 1x, that's 5, 7, 1. Notice the only thing they have in common is a 1. If my GCF equals 1, I write cannot be factored. Okay? You might end up seeing some story problems, but the story problems that they give you for the most part just give you your expression and ask you to factor. Okay, so you might want to look over this one just so you understand it. I think there's one like that in the homework. Okay? Let me know if you need any help.